To bude červený a bude, jo, super.
Tak, klapka.
Hey guys, my name is Václav Tunka and I work as software engineer for Jenkins, and today I wanted to tell you a few things about Jenkins-Koji integration. I hope you know, the guys in Red Hat know what Koji is. Basically it's the upstream for BRUG, but also for you guys who didn't have a chance to get you know, customized with Koji, I will present you some overview. And I hope most of you know what continuous integration and Jenkins is. So in my presentation I'm going to describe how to use this easily as basically open source bundle for clean room production builds, right? So you could ask, like, why the hell should I care, right? Why the hell should I care about Koji or any clean room environment? And the answer is quite simple. Actually you have a lot of customers, and if you have customers for some time, it's possible that they will use some old version, historic version of software. It might not even be possible to find source code for this kind of software. I mean, like, now we are in the age of GitHub, you know, everyone is doing shiny open source development, but look at those closed source companies. You know, the processes aren't always transparent, and you know, they don't have backups of VCS and so on, right? And what's you know, like, also probable is that, for example, the runtime that you are using, you know, such as Ruby, Python, Java, or some libraries might not be available anymore. They can disappear, you know, from the repositories. Google will no longer cache them, and so on. So basically, you will have a huge problem because customer has issue, and you can no longer build, you know, and don't even have, for example, source codes. And your boss, you know, is saying, like, hey, we need to fix it, he's paying a lot of money, so what will you do? So Koji can you know, help you, because it basically has a set of freeze runtimes and dependencies used to build. It allows you to do reproducible builds no matter what. So even like after 5 years, it's guaranteed that the environment will work, and you will be able to do a new build that will provide the exact same output, you know, that is binary compatible, and so on. Then you have auditability. You know who built it. You know who was the guy that shipped the software to customer. Who did, you know, some issue, some bug that was put inside. And of course it's secure. And you can ask, what the heck is clean room environment, right? And I will tell you in next slide. It's basically a way where you provision clean machines, either VMs, images, everything each time. You have separate isolated build routes that guarantee that, for example, some other process or build won't mess with your production code. And you know that, for example, with the VMs, that they are created and destroyed each time. So you know, there is not a chance that, for example, some old dependency that you downloaded and then is no longer available in the repositories or on the internet isn't like making its way onto the production release. And the root of Koji is that all the dependencies are installed from source, basically from kernel up. I will show you in a demo later on. You can have a look how it goes. So in the past, Koji was more like a RPM environment. It was created for the Fedora community and also for Red Hat folks. It uses YAM, it uses kroots and mock. And I mean, now it's something completely different. It can be expanded. It's able to build Docker builds. Docker builds are becoming de facto standard. It's something that most of you will have to solve sooner or later to enable you know, layered builds to make sure that basically your library, you as a developer, you want to make sure that that your app has the runtimes available in the versions you like, not the versions system administrator likes, right? So that's what Docker helps you with, and that's also, you know, but still you need some infrastructure to produce Docker environment in. So and to make sure that it's secure, it's reproducible, and so on. So all the same stuff that apply for RPMs apply also for Docker. And as well, that's kind of interesting for folks that, for example, need to run you know, Java builds, Windows builds, anything. There is a thing called MID, that means like multi-platform enablement, that basically enables you guys to run and install these different environments and produce, I mean, the same clean room environment, even if you don't use RPM, even if you don't use Docker. Basically, you can do, for example, like some kind of like Python build, whatever, and then wrap it up in Docker in another Koji build. So it has huge potential. So here is a short slide about architecture. Basically, in the middle you can see the Koji hub that is XML RPC based. It's kind of obsolete, I know. I will tell you later what problems have I encountered when I developed the plugin. Then you have something called, you have multiple clients. One is called Koji Web. It's like a web interface. I will show you how it looks. Then you have the Koji client. It's a CLI thing. It all operates on top of a Postgre database, and it needs the specific like NFS mounts or local file system paths and so on. And then actually you have the builder daemons that run on the machines themselves, on the images or inside VMs that basically run the build and report back to Koji Hub. That collects the results, stores it, and so on. There is like a permission thing that basically only the Koji Hub and maybe Gojira can touch file system, and if you want to know more, I can show you links and you can study it in more detail. So this is basically how the Koji Web looks like. This is our internal instance we use in Red Hat, and you see like there is a lot of like things you don't care, about. I mean, like some inheritance, you don't care. Some build ID, some naming, versioning. You basically are not interested in that. You just want to have a production build. So basically, if you look at Koji, it was developed 8 years ago. It's written mostly in Python, and also like some parts of it are written in Bash. The API is kind of obsolete and historic. It's XML RPC API. And generally, it presents a lot of obstacles to new users. I mean, the guys that are working in Red Hat know, for example, when they started, how difficult it was to adapt this system, to start basically working with it. You have like the inheritance of build targets, then you have like some target that is shipped, some that is not shipped, then you have some kind of like whitelisting, blacklisting. You need to solve a lot of issues that you don't want to solve. And I mean, most of guys use some hosted instance. So they don't need to care about installing and deployment. But actually, if you try to install it locally, you find it's quite hard. But actually, both these technical issues are solvable. For the complexity, I present the Jenkins-Koji plugin, and for the installation issues, there is a Kocheck set of scripts that my colleague in Red Hat developed, and that make it easier. So, I mean, what's the problem? Why can't you just use Koji, without Jenkins? It's because Koji was never intended to run tests. It was never intended to be a continuous integration server. It was basically intended for production build environment that's executed just once in the end of the cycle. It's really heavyweight. It takes a lot of time till the machine's provision. It's like 20 minutes till all the stuff is downloaded from YAM repositories, till your build starts, and so on and so on. So and then you need basically it doesn't have like any event bus or something, so you need to poll Koji like, hey Koji, is my build ready? And now is it? Yeah. And then in the end basically it's ready, right? But it's not convenient. So as I said, for the installation there is Kocheck script which enable you basically in 20 minutes to install Koji on your local machine. You can either choose that you want a virtual machine, or that you want basically to install it on a local system. And for you it creates all the services, database, sets correct permission, generates OpenSSL keys, and so on. So you have basically Koji environment ready for you, just waiting for you to use it. And then the plugin itself. So I hope most of you know Jenkins. Please, if you don't know Jenkins, raise your hands. Great. That's you don't know Jenkins? No? Or yes?
I wish I didn't know.
Oh, okay, I see. But it's not so bad, right? I've seen some call that basically some tools the developer use, and Jenkins was still like 75%, and I mean like it's open source. Come on, you can make it better. But you can write plugins in Ruby and Python if you want. But anyway, so basically the workflow is as follows. You basically run your builds using Jenkins-CI, you run tests, and once you know that the nightly builds with tests are passing, you will just ask Jenkins to just execute a Scratch Koji build, right? So what's Scratch build? For those who are unfamiliar with it, it's a build that's not put into the Koji database. It's just like some kind of like test build that is garbage collecting. So it's just for you to test that it's sane, it's alright. So basically what Koji does, it builds the Scratch build, then basically the plugin downloads the Scratch build, smoke tests it to see that nothing is broken, and after the tests finish, you can ask the plugin to execute, or you can just configure it like using a template, right? To execute a full build if the smoke test that you defined in your Jenkins job pass, do me a full build and move it, for example, to candidates or to some other location that, for example, QE or some other folks can pick it up. So it's kind of like the plugin is kind of like automated release process, and it's possible to do it, all on your machine, basically in 20 minutes to install everything, use it, and benefit. Okay, so you guys want to see how it works, or you want to hear the issues about API that I encountered and how to make the API better? What do you want?
I think we should jump to the API.
Okay. So I will jump to the API, and if there is time, I will show the demo, or you can have a look later and see at my desktop. So the API thing. Yeah, the first stuff, right? Never use XML RPC these days. Migrate to something usable, whether it's REST or I mean like anything that's kind of like more modern.
Soap.
Yeah.
Soap.
Sorry?
Use soap.
So yes, exactly. I mean, for example, like XML RPC has issues with null or null types. It's not in the specification. Once you have some specification, you choose that you will basically implement your API, and you should not, go around it. You should enforce that and do it, as the specification says. For example, the Koji developers didn't do it. They just like said, okay, well, it's an extension. We will implement extension for non-types, and they didn't care that it broke like all the other languages and all the consumers that were using that. So, for example, when I wanted to use that, I had to like write extension for the Apache web service XML RPC library just to do it. So please obey the specification once you decide what technology for the API you want to use. Then, for example, like the Koji is written in Python. I can show you like details, but please never do it like this way. It's not object oriented. It's just like some set of parameters. A lot of them have like some default values. It's just like kind of a messy code. In Python you have the thing that you consider normal, like keyword arguments, that you say like tag is something, package is something, and that's all, and Python will fill the rest. But please, at least if you want to do it this way, please at least sort it by the most important stuff. Like put, for example, name or type, like in the first 3 argument positions. So if you are not blocking developers from other languages where keyword arguments are not possible, for example. Also, you should think how the types are going to get marshaled and demarshalled, because if you just use some random type, something is integer, something is string, and basically you don't care even what it is. You just like write some API, people will put something inside. You don't care about types. Please at least try to provide some hints. Use method signature to generate how the API will look like. Use some tool to just slightly hint people, and I mean like please don't return like some lists or maps. It's just like non-object way of thinking, because then you need to validate everything based on strings, based on keys. Please use some object that has clear API methods and so on, where it's like basically the object handles the contract and the content. And also, before you decide to publish API that you want other people to use, try to write the client yourself. And if you want to like do it in a fun way, try to write it in different language to see if you are not using something specific. I know that it's nice to just like say that in Python that like this file will contain my API and let Python generate everything, but I mean. It's better if you think about what's API and what's not, and like think about it twice before you publish. Like this is related, right? Like people should limit the usage of the language sugar, syntactic sugar in the API. It's just related to to the point where you will write client in some other language. Ideally, some statically typed language, because it really sucks when you want to use some generic API and at every retrieval or storage of objects you need to like convert it, marshal, check the types, see that basically people put types that you don't ever expect that will be there and so on. So at least like try to document it, like using some doc, and then please obey it. So that's the short. That's what I wanted to tell you. And now I will show you how it basically looks like. So here I have some Koji instance that's running locally, and here I have some local Jenkins. So I will just sorry.
Can you increase font size?
Yep. You see that?
Yeah.
Good. Okay, so I have some really simple build, right? I just say like here is some GitHub repository URL. I will just scroll it down and then just increase it again. So some GitHub URL, and then basically I will say once the build succeeds, just run a couple of the commands, whatever. It's not really important. So I will just say like build now. And let's have a look what it does. Here you can see that some Java Maven build is running, but like as I said, I would like to implement in the plugin support for integration with Docker, so you can build Docker images. And if there is, if people want, I can implement some RPM support as well. So here we see that the Koji task is running. So you see that it allocates some resource and starts the build. And to speed it up, I will just show you how the build looks like. What are the steps? So if you look inside, I hope you can at least partly see that. Oh, it's yeah. You see basically it downloads all the packages from scratch that are requested and installs them, and then basically the build itself starts in the separate environment. So you can then study the logs and details yourself, but you see that in the end we have like a successful build, right? So then in the next step we can just download the build and smoke test it, and if it's successful, promote it. So this is basically what I wanted to show you. I hope that at least it was partly interesting for you, and I would like to just do a quick poll. Who would be interested in Docker builds? From one person, only one, and about RPM builds. No one wants to do RPMs. Okay, I get it. It's terrible. I don't want to do it either. So questions, guys?
Yeah, question. What's the recent attitude from the Java community to RPMs? I always got a feeling, that these two worlds are not
Yeah,
doing
we
together.
hate it.
Well.
It's because I mean it's the RPM was built on the principle that you have like you know, one version of component or dependency, and everything on the system will just use this one version. But this is not possible, because in the ecosystem you have like a dependency tree with number of builds, and for example you have like a logging library foo in version 1.2 which your application use, right? And then you have like some transitive dependency on the class path that uses like foo logging library in version 1.4, right? And you don't have access to the, you know, 1.4 foo to or to the user to just like make the library change it, right? So you want some isolation, and software collections don't really help either. I mean, like Maven handles the packaging for everything, but I mean, I guess for Java, for Ruby, for Python, for all the, you know, different languages, I guess Docker is the ultimate solution, because it enables you to just use the dependencies you like without interfering with the rest of the system.
And my most favorite one is the cyclic dependency. So to build something, you need the same in the build root. It's really...
Yeah, that's great. Okay, please.
Jenkins-Koji plugin in CentOS repository?
No, it's not. You mean like if you want the plugin itself to be packaged? I can show you, if you want, I can show you.
Where do I find it?
Yes. It's basically in the Jenkins repositories, and there is like easy way how to retrieve the. Where do I left it? Whatever. So basically, if you click manage, you can install Jenkins from the CentOS repositories. There is RPM for that and everything, and you will just say manage plugins, and then you say like available, and you will just type Koji, and click, right, and you know, like download this older version, because like you see that if I installed, I see that the Koji plugin is there in version 0.2. So this is basically the way how you install it. Jenkins takes care about that.
So I just install Jenkins, then I install Koji, and then I install this twice.
Yes, that's right. That's right. You install Koji using Project. You can check it here. It's really simple, and you can check instructions for my plugin there, and the presentation will be available on the site, so you can, you know, check the links in peace after that. You know. So if that's all, thank you guys for listening.